what we have done yesterday on Monday is about the set of span S. Okay, we have seen that there are a vector in the big set V is in the span of S. Or another word can be a linear combination of span of S. But there's some can be there's some vector in V can be written as linear combination of vector in S. Another word is in the element of span of S. Alright, today we want to see another definition that is S spans V, or V is spanned by S. Okay, what is this? Let's say we have a set S. V is a big vector space. We say that S span V, or V is spanned by S if the set of span S equal to V. In other words, every element in V can be written as a linear combination of vector in S. So, yes, on Monday we have seen some of them cannot, some of them can. Right. For example number 1, 1, 1, 1 cannot be in the span of S or cannot be written as linear combination of R3. We can see example number 2. Yes, 1, 2 can be a linear combination of R2. Okay, so maybe in example 1, we say that the set S or the set S is not span V, or R3 is not spanned by the set S in example number 1. In example number 2, yes, maybe R2 is spanned by S, but maybe not. Maybe because we have given two vectors in span of S that is not in span of S. So again, R2 is not spanned by the set S that has a vector 1, 2 inside. You got my point? I'm talking about the last example. Yes or no?
Yes, Doctor.
Okay.
Yes.
All right. How to determine? Okay, so this is the, where's my pen? Okay, so we say that V equal to span of S. So this is very important. Okay, next, how to determine whether a given set S, which is subset of Rn, span the vector space Rn or not. Okay, we can use the following theorem. But this following theorem is just for our, but we need also to show that by using the definition. Okay, the proof need to use definition, but the theorem can be used as our guide to say that or to say not. The set S is equal to, the set span of S is equal to V. Okay. Okay, what is the theorem says? The theorem says, let S be the set of that vector, which is a subset of Rn. If M less than N, then we conclude that S does not span Rn. Okay. Again, let S be that subset of Rn. And A is a matrix whose columns are vector. Columns are vectors U1 until Um. Okay. If M equal to N, then S span R of n if the determinant is not equal to 0. S does not span R of n, Rn, if determinant of A is equal to 0. Again, we got this. Let's say we got this, but we need to prove also according to the definition. Again, if we have this, we need also to prove using the definition. Okay, let's see examples so that you can have a clear vision of this theorem. Determine whether or not S span S, set S span V. If S does not span V, determine span of S. Okay, let's see this one. S is a set that contains 1, 1, 2, 1, 3, and V is R cubed. We see here, what? What is M? This is our U1.
2.
This is our U2. That's right. M equal to 2 and N equal to
3.
3. So what can we say?
M is smaller than N.
M is smaller than N. So what is our conclusion?
It is not span. Wait.
S does not
Does not span V.
span R cube.
R
Okay,
cube.
yeah, V. Same thing, Surya.
Oh, okay, doctor.
Okay, so S does not span V or R cube. But we cannot stop here. We need to use the definition to prove it. So, another word, let's see. Suppose S span R3, so that means there is a C1, C2 such that XYZ is a linear combination of 1, 1, 2 and 2, 1, 3. The one that we did before. So we have C1 plus C2 equal to X. C1 plus 2 C2 equal to X. C1 plus C2 equal to Y. And 2 C1 plus 3 C2 equal to Z. Right? Let me write it down. We have C1 plus 2 C2 equal to X. C1 plus C2 equal to Y. And 2 C1 plus 3 C2 equal to Z. So, how to solve this? Again, use the Gaussian elimination. Okay, as usual, I use that operation. Okay, please check. Please check. Is my calculation right? Negative R2. Okay. Take out 1 and negative 1. Sorry. Not more than -1. Take -1 and 2. Got that. I put it here, but I didn't do it. So, there. Have that. So, this one cancel. Any questions so far?
I have, doctor.
Yeah, what do you have?
Doctor, for the third row, 0, 0 stand for 0 and 0 stand for 2x minus 2y plus z. Is it possible?
Okay. What is your answer? Give me the answer.
What is my answer?
Ah,
My answer.
is it possible? And what
It,
does it mean?
no solution, can?
That's right. This is
Okay.
the resistance and no solution. So that means S does not span R3. Okay, we got beforehand just now with the theorem.
Huh?
We conclude that S does not span R3. But we need to prove it using definition. This is definition.
Okay, doctor.
Okay. So in other words, there's no such C1 and C2. Okay,
Okay.
so that S is a linear combination. The set is a linear combination of set S.
Okay, doctor.
Okay, if it is not, then find what is span of S. So span of S is C1, 1, 1, 2 plus C2, 2, 1, 3, right? We want to find what is the form of span of S. So we have C1 plus C2, C1 plus 2 C2, C1 plus C2, just now that we did, 2 C1 plus 3 C2. So if we put this X, Y, and Z, what can we see here? This Z is 2C1, C1 plus C1, 3C2, 2C2 plus C2. So we have X plus Y. So Z equal to X plus Y. Okay, so every vector in this form only can be in the element of span of S. The rest cannot. Okay.
Okay, doctor.
So give me example of a vector that in span of S. Anybody? Any vector in span of S. It must be in the form X plus Y equal to Z. Any other vector that is in span of S. Anybody?
2 C1
Two, what?
plus 3 is equals to 5. Cannot, I don't know. Wait, the 2 C1 plus 3 C2
2, 3,
and 5.
5.
Uh,
So this is one more.
2 to 4?
2 to 4 cannot. Because 2 to 4, yes, can. Sorry.
Okay.
Because X plus Y equal to Z.
Yeah, okay, doctor.
Okay, these are all the vectors that in span of S. Okay,
Okay, doctor.
so another word, not all vector in R3 is in span of
Span
S.
of S.
That's right. So S does not span R3, or R3 is not spanned by S because only some of the vectors in R3 is in span of S.
Okay, doctor.
Okay?
Okay.
Let's try example number 2. Any answer? Any take up for this question? Can you say quickly whether S and V? Can you say quickly whether S span V or not? S span R3 or not?
It is by the term of M and N, doctor, because M and N is equals to M and N is equals to each other.
Okay, you can say that if M equal to N here, right?
Yes.
M equal to 3, N equal to 3.
Yes.
But is that enough that says that S span V?
No, we have to make sure that the determinant of the matrix is not equals to 0.
Yes. What is the matrix, Surya?
1, 1, 1,
1, 1,
1,
1.
2, 1,
Okay,
2, 0.
which you say it by what? 1,
By,
1, 1 by row or by column?
by row.
By row, 1, 1, 1, 1, 2, 1, 2, 0, 0.
Yeah, N.
Okay, but remember in the theorem, I make a circle to the columns.
Oh,
Columns of vector U1, U2, and so on until you end.
so it
So
should be 1.
this show, ah,
It should be
should be
1,
what?
1, 2, and then 1, 2, 0, and then 1, 2, 1, 1, 0. Is it?
Yes, that's right. So the A
Okay.
is 1, 1, 2, 1, 2, 0, 1, 1, 1. It become a column. This is a column 1, this column 2, and this column 3. It's a column vector. Okay, so how about determinant? So we need to find out. Usual, we know the other method. So let's do this. So what we have? 2 minus 4, that is minus
Negative 2.
2. So what can we compute here?
It is not equals to 0.
It's not equal to 0. What does it mean?
It is not equals to 0. It is the span of
So
S
S
in the
span R3.
R3. Yeah.
Right? The others, I need to hear your voice, guys. Not only Surya.
Lama.
He disappeared.
Disappear. Why? Or go have breakfast, is it? It's okay. You can have breakfast while joining the class. No worries. Okay, now can we stop here?
No, not yet, right?
Not yet, because we need to find the C's, right?
Yes.
Okay, so we need to prove by definition. So S span of R3, so that means the C1, C2, C3 exist, and all of those in R, such that for all vectors x, y, z in R3 can be written as linear combination of 1, 1, 1, 1, 2, 1, and 2, 0, 0. So we need to solve for the C's. Okay, as usual. So keluarkan what is the equation? We have C1 plus C2 plus 2C3 equal to X. C1 plus 2C2 equal to Y. C1 plus C2 equal to Z. Okay. Help! Ghost Jordan. Ghost Jordan is helping us to find the C's. Okay. If you don't agree, say so. Kalau saya tersilap. Okay. If you have question, tell me. Next. Okay. We can see here, we can stop here actually. We can see here, the system is consistent. And we have solution for the C's. You want to go ahead, find the C's, go ahead. Okay, because the question only asks whether or not the set S span the B, the big vector B. It doesn't say find the C's. So you can stop here and we can say that S span
Span R3.
Mm-hmm.
So without finding the C, we can just stop here, right, doctor?
Yes, that's right.
Okay.
Because the C's will be in general because we have X, Y, Z. So your C's will be in the form of X, Y, Z.
Okay, doctor.
One more example. Okay, now I want to see somebody write it. Let me, kalau tak panggil nama mesti senyap semua. Let me call upon Julaiha. Julaiha ada. Julaiha, you just tell me whether S-band are 3 or not. Julaiha nampak soalan tak tadi? Whether S-band or 3 are 3 or not, Julaiha. Julaiha.
No.
Julaiha, nak Julaiha please. Ke Julaiha tak ada speaker? Julaiha? Julaiha bercakap tak Surya?
Doktor, saya pun tak dengar. Hello, doktor?
Ya. Saya pun tak dengar. Lang?
I don't hear anything.
Okay, where's Julaiha? Julaiha pergi tandas ke?
Julaiha, where are you?
Kalau tak, somebody else lah. Lambat. Lydia? What can you conclude?
No, doctor, we don't explain it.
No what?
We don't, cannot be expand.
No, what means S does not span, right? S
Yes.
we cannot expand. Of course, we cannot expand. Okay, so S does not span R3. Why do you say so?
Because the determinant.
Lydia,
Oh, Lydia, alamak.
Lydia, why? Why do you say so? Why S does not span, Lydia?
Me?
Yeah, I can hear you.
Because of the determinant,
Because of determinant. Why? What about the determinant?
it cannot be expand.
Why about the determinant that you says that S does not span R3? Why, Lydia? What about the determinant? Did you find the determinant?
No.
Then you cannot answer the question actually.
Mm.
You need to find the determinant.
Okay, doctor.
Okay, Muhammad Farham. Farham? Hello, Farham. Hello, Farham. Ada unmute you. Tengok ni, Farham pun tak ada ni. Nur Azmina. Nur Azmina.
Yeah, doctor.
Okay, do you agree with Lydia just now? Lydia said S does not span R3. But I don't know whether Lydia got from what?
Because
Lydia,
the determinant is 0.
because determinant is 0. Thank you very much, Azmina. Over here, we see that m equal to 3 and n equal to 3. And they are the same, so we need to find the determinant. Yes, determinant is equal to 0. So we conclude that S does not span. Ni salah silap S does not span. So S does not span R3. Okay. So now, if S does not span R3, what is the spanning set of S? In other words, what vector in the set of span S? So we need to find it. Alright. So we have here C1 plus C2 equal to 3. C1 plus C2 plus 3C3. C1 plus 2C2 plus 5C3. C1 plus 0C2 plus C3. Okay, first one, second one, and the third one. Okay, can you see that? What is the relationship between X, Y, and Z? Let us put it in form of X, Y, and Z. Anybody? So if I put in X, Y, and Z, the relationship is there. To X equal to Y plus Z. Okay, please give me example of another vector that is in span of S.
Doctor,
Hmm.
for this part I don't understand. Like, why 2x plus 2x is equals to y plus z?
Okay, if you see here, this is C1, C2 plus 3C3.
Yeah.
What C1? 2C2 plus 5C3.
Yes.
C1 plus C3. So if you see that, if we take, this is C1 plus C1, so we have 2C1, right?
Yes.
Okay, but here's C1. Okay, another one, 2C2 plus 0. So we have 2C2. So we have C2 over here.
Okay.
And then 5C3 plus C3, we have 6C3. We have 3C3 here. So if we times 2 here, we have 2C1, dapat 2C1. 2C2, dapat 2C2. 2 times 3C3, dapat 6C3.
Oh, okay. Okay, doctor. Faham.
Okay, give me another vector in R3 that is in span of S. Another vector. If I put 3 over here. And let me put 4. 4 over here. What can Y and Z? Coordinate Y and Z.
Tutu, madam.
2, 2. If 2, 2. Betul tak? 2. Dia 2X. 2X is 8. 8, 2 campur 2. Tak sama.
1 1 doktor.
Apa dia?
1 1.
4, 1, 1.
Yeah.
Okay, if you put 4, 1, 1. Okay, again 8. 1 campur 1, 2. Salah. Dia mesti Y tanpa Z mesti 2X. So kalau saya ambil 4, 4 ke 2, 8. Apa combination 8? 5, 3. Betul? Apa lagi combination 8? 1, 7.
2, 6.
2, 6. Nampak tak?
Okay.
All those. will be-
Doktor,
Yes.
kalau kosong dengan 8?
Kosong. Boleh? So that means you want to put 408. Boleh?
Oh, okay.
R3. R3 can be anything, right?
Yes, yes.
Pecahan pun boleh.
Okay, doctor.
Okay. One more example. Oh, 44 dah. Tak bergerak ke mana? How about you do 4 and 5? Okay? Anytime, put in WhatsApp group. We'll check together. Try do 4 and 5. I want to straight away go to another subtopic. Boleh tak? Can you
Okay,
guys go
doctor.
Yes.
Yes.
Good.
Okay, doctor.
So 2 definition. Just now is 2 point apa? 3 eh? Wait, apa?
Next satu is 3.6.
3.6 eh? Oh tak. Belum lagi. Ke tak habis lagi? Tadi 3.5 tak habis lagi. Oh sambungan ada kan. Okay. Again do example 4 and 5. Before next class, to me in the WhatsApp group, we discuss together. Okay? Or maybe I point out names so that not everyone put inside the WhatsApp group. Nanti kan banyak lah pula. Okay? Boleh? So, let me point name. Nur Aida buat nombor 4. Nurul Anisa buat nombor 5. Say something, Aida and Anisa.
Okay, doktor.
Aida?
Yes.
Alright, good. Thank you. Tak kat WhatsApp group eh? Okay. Next, about linear dependent. Dependent maksudnya tak depend pada siapa-siapa. Okay, that's what it means. Okay, let S be a set that contains all the vectors and S is a subset of big vector B. If there exists a scalar C1, C2, C3, and Cn, not all zero, such that C1 V1 plus C2 V2 plus blah 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 equal to zero vector. That means 0 V1 plus 0 V2 plus 0 blah blah blah. Okay, so if this exists, if all this exist, not all zero, at least one non-zero. At least one. Yang lain zero tak apa. Itu sebab dia panggil not all zeros. Okay. And S is said to be linearly dependent. Okay, semua faham? Otherwise, kalau if all the C's are zeros, then S is called linearly independent. Okay. Another shortcut way to see whether it is dependent or not. There is a vector which is a multiple of another or can be expressed as linear combination of other vector in the set. Then the set is said to be linearly dependent. Okay. Alright, this one, that what I said just now is this line. The set is said to be linearly independent if all the C's are zeros. Okay? Boleh? Let's go to the examples. Determine whether the set below is linear dependent or not. S is P1, P1, P1. Where the P1 is equal to 1, P1T equal to 1, P2T equal to T, P3T equal to 4 minus T.
Doctor,
Yeah.
just now the before the slide before this, yang bawah
Mhm.
tu apa ni sir? Bawah tu, Doctor?
Wait. This one? This one?
Oh, okay. So C1, C2. Okay, okay. Okay.
All the C's are equal to 0.
Mm-hmm.
All the C's are equal to 0. Then it's be linearly independent. If at
Okay.
least not equal to 0, it's said to be linearly dependent.
Okay, Doctor.
Okay?
So which means that if let's say C1 is 0, everything is 0, and then let's say tiba-tiba C4 is equals to 1, so it is dependent.
Yeah, dependent. At least one.
Okay. Okay, Doctor.
Okay? The rest 0 tak ada masalah. At least one. Kalau ada 2, ada 3, lagi 4, lagi okey lah kan?
Yeah.
Okay. Okay, do this. Independent ke tidak independent? Okay, ni saya salah ni. Ni P2, P2, P3. S is P1, P2, P3. Okay, check whether S is linear independent or not. So we need to find the C's such that CP1, C1P1 plus C2P2 plus C3P3 equal to 0. Masukkan what is P1. C1 P1. P1 is 1. C2 P2. P2 is T. C3 P3. P3 is 4 minus T. Okay. So, need to kembangkan apa yang dapat. What do you have here? C1 plus C2T plus 4C3 minus C3T equal to 0. Gabungkan T, gabungkan yang sama So we have what? C1 plus 4C3 plus C2 minus C3T equal to 0. Okay, next. How to solve for the C's? How to solve for the C's? Yang ni dah senang lah nak solve for the C's. Kita tak payah pakai matrix pun tak apa kan?
Pakai vektor je pun boleh kan doktor?
You try. What do you get?
Okay.
What do you get? Betul tak saya punya ni? C1 plus C2T plus 4C3.
Doktor,
4C3.
C2. Sekejap. Oh, okay. C2. Okay, doktor. Correct. Betul.
C1 plus 4C3. C2 minus C3, betul. So what we get here? C1 plus 4C3 equal to 0. So C1 equal to negative 4C3. C2 minus C3 equal to 0. So we have C2 equal to C3. Okay? Alright? So that means we can put anything for C3. C3 doesn't have to say something here. So let's say we put C3 equal to K. Let's take C3 equal to K.
C1 is equals to negative 4K.
C1 equal to negative 4K, that's right. And C2 equal to
K.
K. Okay?
Okay.
What do you say about this one? See that? We can find the C's, right?
Yes.
The C's must be in the form of where C3 is K, C2 is K, C1 is negative 4K. Okay. So either I want to put like this. Okay. Sama ada nak selesaikan cara tu ataupun cara ni tak ada masalah. Doesn't matter. Tapi yang ni polinomial senang selesai cara ni, betul? So not all these C's are zeros. Let's say I put take K equal to 1. So if K equal to 1, saya dapat ni.
C1. 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 Negative 4
Negative 4 plus T plus
plus, yeah.
or minus T, right?
Yes.
Equal to 0. Okay. So we say that what? S is linearly dependent.
Dependent.
Okay. S is linearly dependent.
Because the C is not all equals to 0, right?
We can find all the C's not equal to 0. Not all equal to 0.
Yes. Okay.
Okay.
Okay, doctor.
Let's try one more example. I have 3 examples there.
Okay.
Oh, you said we can see it this way. We have P3 is 4 minus T. And it is equal to 4 times 1 minus T. That is 4P1 minus P2. So, P3 is a linear combination of P1 and P2. We can also use that and we say that S is linear dependent. Ini siapa yang nampak lah. Okay, we can just go with that argument.